going to do a little bit of a brief overview on the unit circle. I'll try not to go too long on this. I just want to catch the highlights. There are some really good interactive websites and everything that go over this in much better detail than I can ever do. So the unit circle again is a circle with a radius of 1. So r is equal to 1. And we're going to focus mainly on quadrant 1 and look at the patterns. And we're going to be able to apply those patterns to the other 3 quadrants. The unit circle is traditionally broken up into our special right triangles of 30, 30, 30, 60, 90, or 45, 45s. And what we have is we have our degrees, our radians, and our coordinates. So to derive those, I'm going to show you real quick. I'm going to start off with this first one. Let this be our reference angle, theta, right here. So I'm going to be looking at this triangle right here. And remember, r is equal to 1, so we have 1 here. And this is going to be 60. Now, if you remember on our 30, 60, 90, this is going to be a, this is 2a, and this is a root 3. And the beauty of it is that once we know one side, we can compute the other ones. So if this is 2a, a is equal to 1/2. So this is 1/2 right here. And I plug in 1/2 right here, and I get root 3 over 2. So this is my delta x. This is my delta x right here, is root 3 over 2, and my delta y is 1/2. Well, given the unit circle, we're base radius 1, this means this is my y coordinate, and this is my x coordinate. And it works out pretty well. But wait, there is more. Guess what? If we were to do our sine, cosine, and tangent, sine is 1/2 over 1. Sine of 30 is equal to 1/2 over 1. That's just equal to 1/2. And our cosine of 30, which is adjacent, root 3 over 2 over 1, that's also equal to root 3 over 2. So this coordinate right here is my cosine, and this coordinate right here is my sine. Pretty wild. And here's, wait, there's more. Our tangent, which is nothing more than opposite over adjacent, is going to turn out to be our slope. Because guess what? This is going to be our sine over cosine. So that's going to be basically 1/2 over root 3 over 2, compound fraction. You flip it and multiply. So this is going to be 2 over 2 times root 3. This is going to equal to root 3. And you may have learned that before, tangent is slope. Rise over run. Rise over run. Okay, so that's deriving these coordinates here. Now to get this, of course, we're just going to do 30 times pi over 180, and that gives us pi over 6. Okay, let's take a look at our 45, 45. So here we have our 45, 45 isosceles right triangle, where our ratios are a, and a root 2. So dropping our triangle here, again, radius of 1, so this is equal to 1. So to solve it, we do a square root of 2 is equal to 1. A is equal to 1 over square root of 2. We do not like radicals in our denominator, so we get root 2 over 2. Now, being that this is isosceles, this is root 2 over 2, root 2 over 2. So that comes up with our coordinates right here. So again, this is my sine, this is my cosine, and tangent is actually going to equal to 1. And think about it. Tangent is slope. We have a slope of 1. And if you remember in your algebra class, when you have your linear parent function, m is equal to 1. And it kind of looks at right there. All right? Let's take a look at our next one, our 60-degree puppy. Now we just did, look at that. So this is my theta of 60 degrees. All right? So I have 60, my reference angle. And again, I have a, 2a, and a root 3. We already know what's going to happen here. We're basically just flipping this one, and that's exactly what happens. They flip. So this is the basic pattern of our unit circle, our quadrant 1. If you get this memorized, you can pretty much derive the rest of the unit circle. And again, we can find our radians by doing the conversions like here. We just do 60 times pi over 180. Alrighty, and that goes into it 3 times, so that's just pi over 3. So let's start looking at some patterns here. Let me erase this right here. Erase, 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 erase. All right, now, here I have 30. let's follow this line all the way to quadrant 3 over here. Boom, boom, boom. All right? We're coming right across here. Look at the coordinates. They're the same exact coordinates, only now quadrant 3, our x and y coordinates are negative. So that's going to be negative root 3 over 2 and negative 1/2. Same with our 45. We come straight across and we get our negative coordinates, and with our 60 we get our negative coordinates. They're the same. In fact, let's look at the overall pattern. If you notice, the denominator on every single one of these is 2. Every single one. It's over 2. Now get this. Real quick, square root of 1 is just 1, right? So we have 3, 2, 1, and 1, 2, 3. Seen that before. 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1, so on. 1, 2, 3, 3, 2, 1, all over 2. So that's one way to recognize the pattern. And you're saying, oh, good grief, what about the radians? Those are harder to memorize. Well, you still have a pattern. Look at the denominators. They're either going to be a 6, a 4, or a 3. 6, 4, 3. 6, 4, 3, 6, 4, 3. But let's take a look at this pi over 6. Go straight across and you get 7 pi over 6. Straight across. So what you're actually doing is, this is a 180-degree turn. Or a pi turn in radians. We're adding 1 pi. Well, 6 over 6 is 1. We're just adding 6 pi over 6. That makes that 7 pi over 6. We're adding 4 pi over 4. That gives me 5 pi over 4. We're adding 3 pi over 3. That gives me 4 pi over 3. And so on. And the same applies to over here. So you may have to do if you don't get it memorized, you may have to do at least one conversion and say, oh, this is 2 over 3 pi, so that's 4, that's 6, 2, 3, 5. And then straight across here, you're going to add another pi because you're doing 180 degrees or 1 pi. So 1 pi is just 3 pi over 3, and that's going to be 5 pi over 3. Another quick way to remember it. You can also think, okay, I'm going to add 180 degrees. So that gives me 300 degrees, so on. So the unit circle actually is not too hard to memorize. You just got to apply yourself a little bit to it. And then always remember, this is sine, that's cosine. So if you're asked to remember your sines in quadrant 1, your x and y are both positive. That means your sine, cosine, and tangent will all be positive, and so will the reciprocals be positive. Over here, your x is negative, right? So that means that your cosine is going to be negative, your sine is going to be positive, and any ratios we do with that, negative divided positive, is going to give you negative. And then the reciprocals are also going to be negative. Here we have negative and negative. That means your tangent is actually going to be positive plus the reciprocal of cotangent. Here we have our x is positive, our y, now remember this is our cosine and this is our sine. So our x is positive, our y is negative. So any relationship there. So our cosine and secant will both be positive, but the reciprocals of the sine and the tangent will be negative. Alright, so that's pretty much it. A quick overview of the unit circle. And I'll go ahead and get this posted, and we're going to move into PreCal. We're going to get some pretty interesting dicey trig with trig identities and graphing, something you haven't seen in geometry. So okay, I'll go ahead and get this uploaded and go play with my cat because he's staring at me.